Welcome to Hidden Layers, where we explore the people and technology behind artificial intelligence. I'm your host, Ron Green. So here's the question. What happens when AI stops just predicting the next word and starts taking action on its own? That's the question at the heart of today's discussion about AI agents and the road to artificial general intelligence. Some see agents as the next leap beyond large language models, a shift from prediction to autonomy. Others argue we're still decades away and that real reasoning and reliability demand new architectures and breakthroughs we just don't have yet. So the question is, what will it really take to build agentic AI? And when will we finally do it? Will it transform how machine thinks or just remind us how much further we have to go? To understand where this technology is really heading and what's standing in the way, I'm joined by two of the sharpest minds in the business, my co-founder and distinguished machine learning engineer, Zizi Tsai, and our vice president of engineering, Michael Wharton. All right, Zizi, Michael, thanks for being here.
Great to be here.
Thanks for having us.
All right, so let's start off by defining agentic AI and what it means to you. I think this is a term that's getting a lot of traction in 2025, but I think different people mean different things when they say it. Like, Michael, what does it mean to you?
I have a very similar opinion on it. I feel like the term's almost too overloaded, where I'd prefer not to use it and use something more descriptive if possible. I mean, to me, it just is, these systems that can take action now. Yeah. I think in a lot of ways, people always compare them to interns, but in a certain light, I could almost see it as like a marketing hat that we put on top of automation that's got years and years of history of development.
Yeah.
I don't know. Yeah, what do you think, Zizi?
Yeah, I like that a lot. In practical terms, I think, we use coding agents a lot in our firm. And to me, agent really means, an AI that's more autonomous, that can, execute multiple steps towards a goal. Right. And in the process, there may be mistakes. It will self-correct. It can use tools, and it will actually affect your workspace. It can delete your files. It can make your code much better.
Right.
That's what the agent means.
Yeah, and I'm right there with both of you. The way I always think about it is it's something that can handle. It can bring reason, like common sense, to a task, and handle ambiguity in a way we never could before, right? So you can give it a high-level objective, you can give an agent a high-level objective, and it can break that objective down into maybe discrete tasks, figure out, reason through executing those, encounter roadblocks, work through that in a way that you couldn't do with, more programmatic approaches.
Right.
Okay. So, all right. So, I feel like agentic AI has to be the most hyped thing going on right now within artificial intelligence. Everybody's pushing agentic AI. Greg Brockman at OpenAI called 2025 the year of agents. Karpathy on Darkash podcast recently pushed back on that hard. He said, it's really going to be more than a decade. The decade of agents, because he doesn't think that we're really there yet. I've got some strong thoughts on this, but let me ask you this. Where do you see value in agentic AI right now? Is there anywhere that you're using agentic AI? Zizi?
Great question. Yeah. So I think there are a lot of places that agentic AI can be used, and for me personally, I already use it for multiple places. Coding agent is an obvious one. I think right now 80% or 90% of my new code is written by coding agent rather than me.
All right, and you're not vibe coding, quote unquote. You're letting the agent run. You make it. I know this. You make it write tests as well, and when they pass, then you go and examine the code, right?
Yeah,
you don't just accept it.
Yeah, you need to nudge it a lot. That's what I find. The coding agents are very fast, very powerful. They can churn out a huge amount of code.
Yeah.
Sometimes high quality. Sometimes it's in a different direction. If you don't nudge it, it could go in circles. But if you nudge it frequently, it can actually go pretty far. I know Andrew Karpathy in his talk, he probably said that he doesn't he didn't use the coding agent for the nano chat, which is really a great piece of art. I don't even consider that as code. I mean, if you I mean, I've seen different opinions from very good engineers towards coding agents, whether they adopt it or not. Some adopt it a lot, but some really do not like it. I think it really depends on how you treat your code. How do you view your code? If you view it as a piece of art, and you want to express yourself, if you want your design choices to be so densely represented in the code, like in art, then you probably won't use coding agents a lot. But,
and on that, because I've noticed that as well. There are some people who view code as a means to an end, right? They're like, look, I'm just writing this code.
I just want it to work.
I just want it to work. I'm trying to solve a problem.
Yeah.
I'm building an application. And then other people, and I probably admittedly lean a little bit more in this camp, where I view the code as something that I want to be beautiful, that I do care about. Now, I don't care about that, in purely abstract terms, but I do actually care about code quality and stuff like that.
Right. Yeah.
Okay.
Yeah, I completely agree on the coding it, or at least on your side of the argument, Ron. I think it really depends on how far you are into like the individual research, doing things for yourself, and you are the end user of the code that you're writing, versus if you're building something that a whole team is going to have to inherit, if it's eventually going to go to production. I think if the code inherently is throwaway and you are doing some sort of research, that's great. Yeah, if it works or not, and then see you later. It's fine. You saved a day, maybe in some cases.
Right.
But yeah, if it's art that you're building, I would still say that you need to treat code like art in order to build something that's a production quality subcomponent of a much larger system.
I totally agree.
Yeah, I think coding agent is probably the top one kind of killer app for agent right now.
Completely agree.
But I'm curious, what do you think are the next kind of killer apps for agent? One thing I can think of is document understanding, because it's so mundane, it's so boring, enterprisey stuff that is everywhere. People need it. Also, personally, we also have a lot of digital documents that probably can benefit from some kind of agentic document understanding. That's where I started to use it on some of the documents with the personal, locally deployed LLMs.
Right.
But, I'm curious what you think are other kind of applications for agentic.
What do you think,
Michael, what are you using? We're all doing agentic coding.
Yeah.
There's no question there. Are you using agentic AI in any other way?
Personally, I would say not to any reasonable extent.
Right.
I think I obviously use LLMs on a day-to-day basis, just almost as like a thought partner.
Totally.
And that has been a huge game changer. And I think that anyone that's not doing that is probably going to be left behind. It's like not using Google, 10 years ago or even today.
Right.
You're just walking around with an ankle or a weight on your ankle. But I would say I'm not even close to as seasoned as you are, ZZ, in terms of using coding agents specifically. And I'm finding with that use case in particular, there is a lot of slop. And at a certain point, you got to either trust in, like you can quickly verify a system and you just need to trust that the parts you can't see are doing what you expect. Or, in some cases, I find that it does add some work because, if you feel like you need to trust every single line of code that you commit, which I think you should, it just starts getting into this weird, scary territory where you're either risk averse or you're not. I don't know.
Yeah. That's a great point. I share your view that there's a lot of slop generated by even the best coding agents. There's a lot of try catches. There's just a lot of bloat, duplicate functions that you later on when you view it, it's like, oh, why does it do that? And I especially dislike the try catches because I think maybe it's because they're trained to minimize errors that are reported by the code. And one way to shut down the error is just to silence it. But, that's not the right way to.
Oh, that's funny. You mean like try catches where they just eat the exception? Oh, that's
okay.
Funny.
That's funny because in that Andre Karpathy podcast you're referencing, I remember him talking about how you can try to incentivize, or you can use LLMs as judges in the learning process, but they'll always find a way to game things. They'll find these degenerate cases that make it really easy to just blow past, the whole intent behind whatever learning cycle or loop you put it in.
Yeah. Have either of you used ChatGPT Atlas yet with its agentic capabilities?
Oh, you mean the
the browser, the new browser. Yeah,
a little bit. I use Comet a little bit more. Yeah, I'm trying a lot of agentic browsers because I really wanted to automate part of
I'm
my
right there with you.
Yeah.
I've played around with it a little bit. It seems to me that for some reason the go-to example for agentic AI, I think for like the average person, is like travel plans, restaurant reservations.
Yeah.
And it's been that way for like 3 years, which I view as a bad sign, right? Like we're still trying to get relatively simple things like that working. So my take on agentic AI, and I want to know what you guys think on the timeline. I've been saying for a couple of years, you guys are probably tired of hearing this, which is agentic AI is going to be a big deal, but not yet. Like settle down on a personal usage basis. That's fine. It's great for agentic coding. Really great. It's the dominant area. But if you're a business, if you're an enterprise, and you're looking at embracing agentic, you really need to be careful because, we've got the problem if it's 95% successful at taking an action, and then you chain together 20 actions, which you want to do. That's kind of the point of these agentic systems. Is your probability of success really diminish?
0.95 times 0.95 times 0.95. That gets small pretty quick.
It gets small pretty quick. And so I find myself in this weird place, and I feel this with several different AI technologies. I am as excited and bearish as anybody out there, but I also feel like sometimes people want everything now. And if you look at again, going back to the Karpathy episode with Torkesh, he was saying everybody settle down. It's going to be 10 whole years till we have AGI and agentic systems. And if you stop and think, that's crazy. I mean, that's just 10 years. That's kind of nothing in the grand scheme of things, right?
Yeah.
And he's considered to be quite pessimistic by a lot of people, just saying it could be a decade.
Yeah.
Where are you on that? I want to know what you both think about the timeline on real agentic AI, where you can interact with the system and give it a meaningfully difficult goal.
Yeah. I feel like it really depends on the use case. So on the one end, there's the autonomous driving where the penalty or the cost of a mistake is so high that it's human life. To somewhere like, hey, brainstorming some ideas for my next story to tell my kid,
Right.
So I think it really depends on the use case. So I like your example, Ron, about the agentic browser. As a hobby, I'm also trying to build an agentic browser myself.
I love it. Of course you are.
With coding agents. And it's hard. And the reason I think it's hard is that there are so many kind of edge cases and long tails. If you wanted to work on one side, maybe it's feasible. But if you wanted to work on, all the different sides, form filling, and especially if it's handling your sensitive information, filling out the credit card information, and you don't want it to accidentally just hit the buy button, So just making sure that all the edge cases, the 99999 that's mentioned by Andrew Karpathy, if you're expected, your required accuracy is 99.99999%. Each 9 is gonna be a lot harder than the previous step.
It may take as long as that previous 9, right? Each reduction in error. I think that's actually true, and I think that's the reason I'm excited, but I want to just temper the hype a little bit.
Yeah.
Where are you on the timeline?
I tend to be a little more pessimistic too. I think the agentic AI this year feels almost like a solution in search of a problem in a lot of cases.
Yeah.
And I know the Gartner hype cycle isn't like the most rigorous thing in the world, but it's a good mental model of how these hype waves kind of play out. And I think something fuzzy and subjective happened in the last 3 months to 6 months maybe, where I feel like we crossed the top of that peak of inflated expectations. I think there are some real sobering realities that people are starting to get become aware of. But at the same time, there's so many mini technological revolutions that keep happening. Computer vision was huge in 2012 and beyond. Fusion models under LMs, you got agents, you got personal assistants, whatever. There's still a lot of innovation that's happening. I just think 2 things I think are interesting. One is the importance of experts seems to have gone the opposite direction that people thought. Most people were like, oh my God, we don't need experts anymore. We have LLMs. They can do all this stuff. And now it's almost like people are coming to the reality that it's a tool that can maximize whatever capabilities you already have. So, given that, I think we're still limited by whatever the speed limit of humans being involved is. So I think the rate of progression is probably still going to be smooth until we just totally hand over the keys. The other thing is, I guess it's kind of related, but we are a speed limit, and like humanity, we have to refactor society and do all this stuff to respond. Even if we had artificial superintelligence today, we need to meet that technology and capability somewhere in the middle in order for it to actually transform society. And I don't think we're built for it right now.
Yeah. That's a really great point. And this actually reminded me of another point that Andre mentioned in the podcast. So he's consulting for other companies to adopt AI, I think. And, he mentioned that oftentimes he would advise against using AI because, there are other solutions that is better. I think, for us, it's recommending and, advising companies to adopt or not adopt agentic AI. I feel like, maybe a few years later, there's a lot of adoption of AI. I mean, people use AI too little.
Yeah, exactly. Yeah.
And in recent years, maybe people get too excited, and there's a little bit of over adoption in some use cases. Still, I see under adoption in other use cases. But
it's funny. Okay, so I think us three and most of the people we listen to, we live in a little bit of a bubble. It's like a digital bubble. But I gave this talk this week up at a group of aerospace students in DC, and I was trying to get kind of teed up with getting a sense of the audience. I was asking a couple questions like, okay, raise your hand if you use LLMs on a day-to-day basis. And one person in the room raised their hand.
Oh, wow.
And this was like, it was like 50 people in the room or something.
Wow.
And I was like, are you kidding me? Because if I would have talked to people that look like us in a similar room, it would have been the entire room just like,
oh yeah.
I thought it was just a no-brainer, but that shocked me. And I think, to your point, ZZ, there's this rapid, aggressive adoption with people that kind of look like us, but the rest of the world catching up is going to be a really long journey.
God, I think you're right. ZZ, I want to dig in a little bit more on what you said, because I think I really agree with your sentiment, if I understood it. When you say companies are maybe underutilizing AI right now, can you give me an example of that?
I feel like there are a couple of different use cases, a couple of different scenarios, but I'm very curious to hear your experiences too. So I think part of it may not be purely technical reasons. So like there are maybe cultural reasons, or just inertia. Like people just do not feel they want to try a more risky thing, or that there is a fear of this new thing that may take over the workflows, that may take over jobs, while in reality, if you adopt it, your efficiency gets better, and your capacity to serve your clients become better. So I feel like there is sometimes irrational fear or resistance that kind of contributes to adoption of AI, where I feel like internal workflows, especially like the mundane, the soul sucking part of the job, that can be automated, especially I would say, document understanding and automating very tedious kind of routing of the workflow, coordination of people's schedules. I just wish that we, collectively we can spend more time on creating useful things and helping other people to have a better life, rather than fighting my calendar, always be in meetings, stuff like that.
Yeah. I can't believe I'm going to say this, but Gary Marcus wrote something recently that I agree with, which I never thought I would ever say that. But he's a long-term critic of LLMs and AI, and very much a pessimist and dissenter. But he had an article, I think it was in the New York Times a couple of weeks ago, where he was talking about too many companies are rushing forward and trying to leverage generative AI for every problem. And they need to pause and think about domain-specific AI, right? Meaning, what I mean by that is AI that is really good maybe at one or two or a handful of tasks, but is not a general AI. So an AI system that might be incredible at reading X-rays or detecting fraud or doing loan factoring or foreign object detection, all these types of things that are examples where it's narrow, but these systems have superhuman capabilities. And to me, that's probably the thing that I'm most disappointed with right now in AI adoption is that everything you said, ZZ, I completely agree with. And then I would add on, too few companies are taking advantage of their proprietary data and building narrow systems. And here's how it ties in with Agentic AI. And this is what I think will be the future for the next few years, which is agentic systems that can reach out to these narrow AI systems. So for example, if you're dealing with an agentic system right now and it needs to calculate some numbers, we know LLMs are terrible at that inherently. You want them to have the ability to call out to a calculator, right? To some external service, some external skill. Well, I think once we start embracing these narrow domains a little bit more readily, we're going to have these AI systems that will be superhuman, but they'll be aggregated out. They'll be federated, and I think that's going to be one of the real keys to getting agentic AI into the enterprise.
Totally. And that's a long uphill battle too. Like that's not something you do overnight.
That's right.
And I feel like there's this universal temptation right now to just kind of prompt engineer and ask an LLM what an answer is. But I think most people that have worked with them enough to, in serious context, have found you can't just upload an image of or like a mammogram or something and ask, is there cancer here?
That's right. That's right.
It's much more complicated than that.
Yeah, I think I shared some of the things here. Like when I use coding agents, I don't remember how many times I type ls, just trying to list the files. But I type it to the coding agents.
Right.
Yeah.
Okay, so I want to kind of do a segue now. This is the other big topic I want to talk about, and this is the AGI timeline. But I really do think it's deeply tied in with some of the topics we've already discussed. I don't know. Oh, but I have so many thoughts here. I don't know if we will have true agentic AI until we have AGI, in the sense of agents that are capable of doing all the different things you need to have them do, are of course going to have general intelligence. Now, that said, you both know that I feel like the goalposts keep getting moved on AGI, right? Meaning, I think for really any reasonable definition of how it would have been defined 20 years ago, we've achieved AGI. More and more, it's no. You need to be capable of any human skill, including now people are assuming physical capabilities, like embodied capabilities. Right. So this is what I want to ask you both. And there's a component of sort of biology here, right? How much do we need to borrow from biology as we improve these thinking machines? Are we blocked? Do we think we can get to AGI with the current architectures, or are we going to need wholly new ideas? And independent of that, what's your timeline for achieving AGI? Do you guys agree with Karpathy that it's a decade away? Do you agree with some of the really excited people in let's say the Valley who think it's next year? ZZ, I want your thoughts on that first.
Okay, yeah, this is a really good but tough question. I'm actually more pessimistic than Andre in terms of the timeline for AGI. That's really because my definition of AGI involves physics,
embodiment, right?
Yeah, I feel like it's more than 30 or 50 years because hardware is very, very, very hard.
Yeah.
And because of the kind of the 99999, you really need to get to high precision for certain tasks, that are sensitive for error. But what's your other question again?
Well, I'm just kind of curious there. So on that AGI timeline, do you think, and again, you're including embodiment, which I think that's fair. I think if you include the ability to move in a 3D world and do any physical task a human could do, which, for example, would include playing sports, at a professional level, right? We're probably decades away from that. But outside the embodiment issue, do you think we need new architectures, new approaches? Are we too focused on scale? Are LLMs sucking all of the research and money away from things that might be more biologically inspired?
Yeah, I feel like both model architecture as well as the training algorithm, there seems to be still a lot of room to improvement. In terms of model architecture, if you look at the recent kind of Kimi, K2 thinking model and its previous models, they made some interesting architectural change to make the transformer layer more like a linear attention layer. So it's also kind of related to Mamba architecture, and that is more efficient. And given the recent success, it seems like there are still a lot of upside to investment in the model architecture change. So I'm pretty optimistic. In the next few years, maybe we will see some actually new architecture than the transformer we have been on for 10 years.
Yeah, 10 years now.
And then the other side, I feel even more optimistic is, the data that we use to train the models or the simulators, the world models that we train the agents within, as well as how we teach the model. And that's where I feel like we can learn a lot from human biology. Well, not really biology, but, learn from the cognitive science, where I think right now, the way that we pre-train and post-train LLM is already pretty similar to how humans learn.
Right.
Like the pre-training is like.
Oh, you think so? You think it's similar to how we learn?
Love to discuss about that.
I think I know where he's going.
Yeah,
go ahead.
And this actually relates to some earlier tweets from Andrew Karpathy.
Yeah.
Well, he really releases a lot of super valuable insights. So. Like the pre-trains, like just reading a lot of book without fully understanding it. Just read. In China, there's this saying that if you read the book 1,000 times, the meaning emerges to you. So it's like just reading a lot, and then it becomes kind of implicit knowledge, and you can apply it just by muscle memory. So that's the first stage. And then supervised fine-tune is like the teacher doing math problem on the blackboard, and then the students follow just the step by step. And then there's the RL where you're just given exercises where you will trial and have the chance to fail and learn from your mistakes.
Right.
So that to me is like already kind of a good analogy to how humans learn. And I think there is a lot more that we can explore. For example, I think the recent Thinking Machines blog post about the on-policy distillation, where it's like you have a strong teacher model that critique the student's generation step by step, not like just providing the reward at the end, but just when the student model does it, the teacher give feedback that is dense, so that you don't have to suck the supervision from the straw.
Yeah, exactly. I have so many things I want to jump on here. I agree with everything you said, ZZ. That comment at the end about reinforcement learning and sucking signal through a straw, and that's the problem. You only get feedback at the end. That is one of the biggest problems with reinforcement learning, and these new approaches where you just much denser signal, I think, is huge.
Yeah.
And the other thing I've heard, and tell me if I'm wrong about this, but I've heard pre-training, I think, again, even by Karpathy, sort of analogized to evolution. This idea that, an LLM has all this knowledge sort of baked into their DNA, into their parameters, right? And that is a starting point. It's the reason like a baby zebra can be running within hours. That's not enough time to learn that.
Right.
And there's an element of that with LLMs, but then you have to, the biggest flaw is the ability to learn or improve over your lifetime, right? Which we have very few things even remotely capable of that, which is why I think skills and as an external mechanisms for agents is so important. So I really, really like that approach. And Michael, I want to hear what you think.
Yeah, actually hearing you frame it that way it makes more sense to me. Because when I think about pre-train, I think about like the data inefficiency probably compared to how humans learn.
Humans
think
much
about
better.
Like the like neural correlates of consciousness, like all these things that happen in your brain that seem so fundamentally different to how we've engineered these artificial intelligence systems in a lab.
Mm-hmm.
Like the fact that we train these systems with gradient descent, whereas in the real world seems like there's like Hebbian learning or something like the neurons that fire together, wire together kind of thing. It seems to me like there's this huge gulf between what the neurobiology folks and the neuroscientists are looking at and interested in and what the computer scientists are interested in. And I don't know this for a fact. I'm really curious what y'all think. But I get a sense that one hand is not really talking to the other as much as they should be. Occasionally, I'll look at a comments thread on a Hacker News post from a paper or something, and you'll see these people that chime in from the neuroscience world, and they're like, "We figured this out 20 years ago. Like, what are you guys talking about?" I've seen that on multiple occasions, and it almost seems like this adversarial relationship. Whereas, I think this transition to AGI, regardless of how you describe it, is going to be a pretty smooth process.
Yeah, I agree.
And you think about how our brains evolved. There are all of these subcomponents and subsystems that you can see evidence of in other animals. These are things that have evolved for a long period of time, and they've kind of been honed and tweaked. I don't know if what we're doing right now, is it just sensitive to initial conditions? Is it sensitive to the weird relative configurations of these subcomponents? Something I think that's really remarkable is how little we use genetic algorithms in our modern, way of doing AI. I'm curious what you think, because that's your bread and butter. Obviously, it's computationally expensive, but are we underutilizing genetic algorithms? Or
I definitely think we are. In fact, I think I just saw it was yesterday or last night that Alpha Evolve came out with another paper. Have you guys seen this yet? And they, I only read the abstract really briefly, but they ran it on like 60 known solved problems in mathematics, and it was able to, if I recall correctly, improve on 20 of those. Right now, they do say, there was a human in the loop and it was guiding it and things like that. I do fundamentally think that there is probably an overinvestment into, gradient-based learning systems like deep learning and things associated with that, but it's natural. We definitely should be looking at other.
I'm not like looking at gift horse in the mouth. Or
exactly, it works. We should be spending more time thinking about reinforcement learning. Well, the industry's doing that now, right? In the last few years, that's really had a renaissance. I think evolutionary techniques are in a way sort of the final frontier. In that you can bring them to. You can bring them in any party. There's not a situation in which evolutionary techniques fail because they almost need nothing, right? All they need is the signal on fitness at some point. There's no gradient. They can handle incredibly sparse rewards. Of course, the downside is, evolutionary systems can be highly inefficient. They can be parallelized pretty well, but they can be really, really inefficient because they're operating without a signal. But generally, I think we'll probably see, my guess is in the 30s. It's kind of wild to say this. In the 30s, I think we're going to see a complete renaissance on the evolutionary side.
Totally
Interesting. So that actually brings up another point I want to ask you all about, which is that it seems like humans use the world as a really crucial source of entropy in the process of learning. Like there's just a lot that we get from the environment that we operate in that allows us to generalize. It's like a forbidden experiment, but if you dropped a human into like a featureless sort of world and just watched what happened, I don't think intelligence would just naturally emerge. Like, it seems like the environment's important.
Yeah. Oh,
and we don't
absolutely
have that with just like pre-training on 15 trillion tokens as much as we would.
I think that's true. And I mean, there are experiments, one of the most famous being, it's a little sad, but they would take kittens, and you may know this one, where they would sew their eyes closed when they were little, when they were just born. And I believe these researchers won the Nobel Prize for this, because they showed that if you don't let the visual cortex receive signal for some period of time, those animals can never learn to see.
Wow.
So it's literally baked into your biology. And there are other experiments like that as well. So I think, we're the product of billions of years of evolution. Our bodies know the environment. We thrive on that entropy from learning. And if I was going to critique the current architectures, that's the thing we're missing the most. These are models that for the most part are frozen in time, and we've got to get better about them learning over their lifetimes.
Yeah.
It's so inefficient right now from a computational perspective, and they're also just sample inefficient.
Yeah, I'm a big fan of lifelong learning. This is a human ability that is not replicated in any of the LLMs yet. Even the strongest coding agents, the next day when I ask, hey, okay, what do you think is the next for the project? Well, sometimes it can read the previous conversation history and recollect some, but it's never feeling like it's, like a colleague.
It's almost like I've been coming to think of LLMs as sort of like, it's like you have this amazing library that you have access to. A lot of it's retrieval. And then you have a moderately smart librarian that's at the front that can go like synthesize all of it for you. But for the most part, it's an exercise in retrieval. Yeah. There's some cognition, but if you strip it away to that cognitive core, there's relatively little cognitive residue left over. And a lot of it's just kind of memorized.
Yeah.
Facts and patterns,
I totally agree. Okay, I think that is a perfect place to stop the podcast, guys. Thank you so much. That was an awesome conversation.
It's so fun.
Thanks.
Thank you, Ron.
Thank you for listening to Hidden Layers. This series is hosted by KUNGFU.AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at KUNGFU.AI.